All right, let's get started. So in the first few webinars, you have seen how we have built an Axon bank application, and it's an application that allows you to create an account and then transfer money from one account to the other. A fairly simple application. So let's move quickly to the code. It is a Spring Boot application that we have created last time. I've shown how to use the @enable Axon to allow you to define specific defaults. So you will automatically have Spring Beans for the command bus, event bus, etc., etc. This time we're going to improve on that a bit. In the meantime, since the last webinar, we have released a release candidate 1 of Axon 3. Which builds more features that we can use, and I will show you how they simplify this configuration. Furthermore, we had our a little API here, allowing us to define. Well, it defines our commands and events. In this case, to create an account, withdraw money, and deposit money, and the same events that or the events that belong to those. On the other side, we have the transfer, where we can request a money transfer. Then there's the event accordingly, and then we can complete the money transfer and cancel. That is not something that a user will do from the interface, but there is the money transfer saga that we've seen in the last webinar that executes that. We're not going to touch too much on that. But first of all, let's go to the dependencies, and I've already included the RC1 version. But besides the Axon Spring module, there is now an Axon Spring Boot starter that you can include instead. It will give you one extra dependency, which allows us to simplify our application. First of all, we do not need the entity scan or enable Axon anymore. Secondly, we see here the serializer, which we define, which is the extreme serializer. That's the default in the Spring Boot starter. The entity manager provider, is also the default. We don't need to specify that because the starter detects that we are using JPA, so it will automatically define that for us. There's a transaction manager, it will define that for us as well. And since we use JPA, it will also assume that you want to use the JPA event storage engine, so we can remove that as well. So this is a lot simpler. In fact, this is the default Spring Boot application that you get. We can run this application. Which takes a while. And as you can see, nothing really special happens. We can go to our localhost 8080, and this was a very simple API. It just executes a set of commands: create account, and then transfer money between the two accounts. And as you can see here, doing that has caused a number of commands to be executed and a number of events to be handled. These events are handled in a logging event handler, which is just a component. It receives all events and then just logs that an event was received and does the toString of the event. Nothing really special. So we're going to improve on this application because there's no query models and there's no output on the front end. So let's build that. Let's create a new package, and I'm going to use the name query, which is not a very good name in practice because it's a technical packaging structure. Normally you would want to choose a name of the let's say intended audience of your models. So what is the model intended to do? We're going to create a model that shows us the current balance for any account based on the last event that took place on that account. So we can call it the account balance event handler. All right. And we make this an add component, so that Spring picks it up. Let me switch off the inspections. And then we create an event handler for it. So what we want to do here is react to any balance update events that occur in our system. So on balance updated. So this balance updated event is the abstract event which is extended both by the money withdrawn event as well as the money deposited event. And that event gives us the current balance, or the balance after the withdrawal or the deposit, which makes it very simple to implement this. So this event gives us the state that we actually want to store in whatever we want to store the model in. So we want to update something. We could, well, let's create a little JPA entity, which is our account balance. And the account balance contains an ID, which is the identifier of our entity, and it contains a long, which is or int, which is the balance of the account. It always hurts to create getters and setters, but sometimes they don't bother too much. All right, default constructor for JPA, and we can also create an account balance repository. Which is an interface we specify at repository. And what I'm doing now is Spring Data JPA. I can extend JPA repository for an account balance object which is identified by a string. And this gives us a repository where we can load and store account balance objects. So I can define that in here, account balance repository. Add it as a constructor, and then I can use it here. So I can save a new account balance for event.get account ID and event.get balance. So as you can see here, there's a number of objects that or methods that you can invoke to find out if an object exists or if it doesn't exist, and etc. We can find all, find one, etc. So let's see what happens when we create this. Of course, we need some way to expose this information, and well, we can do a little dirty hack in Spring. We can make this a REST controller instead of just a component, and we can do a little get mapping here for /balance/ID, and we can get an object out for account balance, get balance. And we can load find one ID. So this gives us a URL where we can go to ask the balance of a specific account. And as you can see in our previous run, we have created an account with ID 1234 and one account with 4321, and they have done a money transfer. So one of them should have money in it, and one of them should have a negative balance. So let's restart the application. oops, localhost 8080/balance/ID. I'm actually expecting nothing, and the reason for that is we have submitted, we've created the event handler, but by default the event handler is a subscribing event handler. So this object has never received events. So we can do two things, and first of all I'm going to clear the database. Where's my window? Okay, that's fantastic. Oops. Where did my window go? Ah, it's in an invisible screen. That's lovely. Move. All right, playing around. Move. There we go. Let's refresh. We have some auto-created tables, including the account balance, but we need to rerun the application entirely, and that's because of our hard-coded account IDs. So let's run the application again and trigger all the events that we did with our in our controller. All right. So first of all, we go to localhost 8080, which was the URL that triggers the creation of two accounts and a money transfer between them. And now we should be able to see the account balance. So we have an account which has a balance of -100, and we should see the balance on 4321, which is a balance of 100. That's lovely. So this is how we can create a model that will react on these new events, but of course we have a problem like we had now, where you have an application that has been running for a while and you want to add new views to this. So let's simulate a situation where that happens, and so let's create an entirely different model, and let's create that let's call that, let's say you want to see a transaction history. So we want to see a transaction history, updater, event handler, at component. Well, let's make it a REST controller right away. And we want to do something very similar with the transaction history. And of course, we've had events in the past right now that they have occurred, and we want to reconstruct the history even of the accounts that have already been around for a while. So let's create again a private transaction history event handler, repository. And we create an interface with that name, which extends the JPA repository for a transaction history object identified by a string, which is again the account ID. No, that's not true. It's going to be identified by a long. We just create an automate increment identifier. So let's create that object. It's an entity again. We create an @ID private long ID. Generated. It's a generated value. Then we have, private string account ID and private. So what information did we put in a withdrawal? So let's say we just want to know if we withdrawn or deposited money. So Boolean deposit. Oh no, let's just do int amount. And it's a positive amount for a deposit and a negative amount for withdrawal. We create some getters and setters as well. Create a constructor for those. And we create a constructor with no arguments for JPA. Alright, so now we can create an event handler, and in this case we want to create two event handlers. Public void on money deposited, and we want to say repository dot save new transaction history object for that specific account, and this is a deposit, so we take the amount as a positive number. In the other case, we have the money withdrawn event, and we want to negate the amount that we have withdrawn. So this should give us entries in the database that well, basically record all the pluses and minuses. And let's create a get mapping for that as well. Public void on find transactions. Sorry, find all. So let's find all transaction history. And of course we have to pass in the account ID here. Account ID. So let's create a constructor for that as well, just to no. All right. Let me try something else. What I'm going to do is, instead of using this repository, just use the entity manager. Otherwise I'm going into the JPA examples API, which I really dislike. So let's add a constructor parameter. We remove that parameter like so. And then we do entity manager persist instead, like so. And we create a query where we select TH from transaction history, where TH dot account ID equals account ID, order by, well, we don't have any ordering, let's order by ID. Alright, semicolon. We're going to set a parameter, account ID, to that value, and then we want to get a result list. All right. And this is actually what we return. Like so. Of course, we need to have a proper get mapping, otherwise we have a conflict with the other one. So we do history / account ID. And we need to specify this as an path variable. All right, so we need to restart our application to get this done. And we should be able to get to the /history / account ID. And again, see nothing, right? Because we are still in this subscribing mode. So we are getting, this one still works. Localhost 8, oops, shouldn't have done that. So probably our account balance is now, okay, that's good. It's empty. Which is what we expect because there's no events passing by that could have stored our history. So what we want to do instead is make sure we can replay this event handler from the beginning of time, at least for as far back as the application is concerned. So to do that, we need to tell Axon that we intend this event handler to be part of what's called a tracking event processor. And one way to do that is assign this event handler explicitly to a processing group. And if you don't do this, then it will be assigned to a processing group with the name of the package that the class is in. But let's say we want a explicit processing group for transaction history. What I now need to do is tell Axon that I intend the processing group of transaction history assigned event handlers to be part of a tracking processor. I can do that quite easily. I can say event handling configuration. Oops. And I can say config.register tracking processor our transaction history. So I'm now telling Axon I want my transaction history group to be used as a tracking processor instead. Now we can restart our application. And it will get to work right away, as we see. And now we have some account history. So we have seen that there's money deducted from the account. And of course, we can also see the other one, 4321, like that. This one has the other way, has it the other way around. And so as soon as the application started, this processing, this tracking processor will go to the in this case to the JPA token store and discover it has no token yet. So what it will do is restart from the beginning of the event store and track its way through all the events that have occurred and start processing those as fast as it can, trying to catch up with the events that are being stored in the event store right now. So what our application is really missing right now is a way to trigger a money transfer specifically to transfer money from one account to another. So let's create another request mapping for /transfer, and let's say we have source / of course I could create a nice JSON API where you put and post, etc., but that is going to take a lot longer to get the commands across in a browser, so I figured this is the simplest way. Public, let's give back a string. String source account, string destination account, and let's do a long no int. We don't have to transfer that much money at the same time. So now we can do a command gateway.send new create account. No. Request money transfer command to transfer money from, well, the ID is a random. The source account is source account, target account is destination account, and the amount is amount, like so. And then we return, whoops, okay. And we need that to be a response body. We need add path variable here. All right. Unfortunately, we need to restart the application. Now, in this case, the restart will not cause the transaction history event handler to restart from the beginning again, because it remembered the last token that it had processed. We can actually see those tokens in the database. So we have our token entries here. We can select them. You can see here that there's a processor named transaction history, and that processor name is the identifier of the token that's being used. The token itself is some serialized data that we require. There's a specific token type. There's an owner, so you can have multiple processes, and we make sure that you don't have multiple processes triggering the same events. And there's also a timestamp, and that timestamp is updated as the consumer is trying to pull the database and find new events to process. And if it can't find these new events, it will still update the token so that other nodes can see that the owner is still alive. All right, we have started our application again. So now we can go to localhost 8080/transfer from 1234 to 4321, an amount of 50. All right. You can't have it all. All right, that's because we don't have the right mappings here. That makes sense. Let's try again. Application starts. We do our request, we get an OK back. Now if we go back to our account history, we see that there's a second entry now, which is the event we just generated. And of course we can transfer a few more. Let's do a small amount, and I press F5 a couple of times, and F5 here, and you see these events being processed. And of course you can see by the identifiers that there's a gap of 1, which is probably the account that's being depleted at this point. So this is how you can define a tracking processor. Now we could also say that maybe we don't like our transaction history. There's only an account ID. There's an amount. But if you look at the events, we also store the transaction identifier, and maybe that's something we want to include in the application as well. And this is a very common requirement, that you need to add data to your view models that you don't have. So there's no other model that you can get it from. So the only way to get it in there is restart the processing from the beginning. So let's do the transaction ID in there. I think that's what we called it. Yeah, there's a transaction ID in the withdraw and the events. So let's add the transaction ID in here and assign that to the value. create some getters and setters for them, and that's it. So I have set Hibernate to use the update, so it should create a column automatically for the transactions. But actually, since I'm rebuilding the whole database, the data that we currently have, even though we have our tracking token already, but the data we have already is not what we want it to be. So we're going to clear everything we have on this database. So let's update the event handler as well, and of course here we need the event.getTransactionID as well. So now we can actually correlate the withdrawal and the deposit. So before we restart the application, let's stop the application, go back to our database, and we can see that the accounts balance table that we currently have, this is not what we want it to be. So we could, well, we can just delete the table in this case. We just drop it. But what we also need to do is make sure that the processor will start from the beginning again. And the easiest way to do that is by just deleting the token. Whoops, not the value, the entire token. Delete rows, apply. All right, so now the table is empty. When the processor will start again, it will not find a token and start from the beginning. And it should then include the transaction IDs of all the transactions that we have done in the past in our view model. In practice, if you have an application that needs to service a client while you are doing the migration, which is quite common if you have a lot of events, because it will take a while for the view model to update, you probably want to create a separate view model that starts from the beginning and then phase out the old one when the new one is up to date. So let's go back to our history, and now we have transaction IDs in there. So the transaction IDs here are null, because that's, I think I have deleted the wrong table. Let's refresh. Yeah, I removed the account balance table, not the transaction history table. Well, no problem. We have bugs in real life as well, and we fix them. So let's drop the transaction. Well, now you can truncate it. And again, we select the tokens. We just delete that token like that, and now the token is gone. We restart our application. Press F5, and now we can see, let's make it a bit smaller, we can see our transaction IDs in here as well, together with the amount. So this is how you can update view models and then just do a replay from the beginning of time automatically, simply by dropping the tracking token of a processor. So just to reiterate over what we have done is, since this event handler is in the same package as the other event handler, by default they will be assigned to the same processor. But since we wanted one to remain subscribing and the other one to be tracking, we have to explicitly define a different processing group. And of course we can do that by putting it in a different package, but we can also use the add processing group annotation to explicitly define where it should go. And then we have, in our application, we have configured that specific group should be placed in a tracking processor. And for the rest, this configuration uses sensible defaults, so it will use the default tracking token store, which in our case is a JPA token store, because the Spring Boot starter application detects JPA. If it doesn't detect JPA, it will try to use another one and eventually default to an in-memory one, which is not a very good default for any system in production. So if you don't use JPA to store data, explicitly configure a token store where you want to store the tokens for your processors. That's basically it. So we've seen our different processors. We've seen a replay. We have fixed a little bug in our tracking history. We have replayed the transaction history to add new features that we could never have implemented if we had a plain model. But now, based on our event history, we could just process everything as if it happened today. So that concludes this third and last session.